Hello, in this video we're going to be covering section 3.5, transformation of functions. In this section, the students will graph functions using vertical and horizontal shifts, graph functions using reflections about the x-axis and the y-axis, determine whether a function is even, odd, or neither from its graph, graph functions using compressions and stretches, and combine transformations. First, let's talk about vertical shifts. Given a function f of x, a new function g of x equals f of x plus k, where k is a constant, is a vertical shift. So if we're adding a number to the function, that's going to shift it vertically. So all the output values change by k units. So this is probably important for you to note for later. If k is positive, the graph will shift up. If k is negative, the graph will shift down. For a horizontal shift, given a function f, a new function g of x equals f of x minus h. Now notice here we're adding k to the outside of the function, so adding k to the whole function. Here we're subtracting h from x, just from the x, where h is a constant, is a horizontal shift of the function f. If h is positive, the graph will shift right. If h is negative, the graph will shift left. So we're going to do these shifts. So if you look at the first function, g of x is equal to f of x plus k. In this case, k is negative 2, so we're going to do a vertical shift, and it's negative, so we're going to do a vertical shift down 2. So all we need to do is take each point on the graph and move it down 2 spaces. So let's see. Okay. So what we're going to do is we're going to pick several points on this graph that would be easy to shift. So take that point, this point, this point, this point, and this point. And we're going to shift these points down 2. Now notice we're counting by 2s on this graph. We're counting by 2s already. Alright, so I'm going to go down 2. So it looks like I only went down 1, but remember the graph is counting by 2s. So I'm going to take this point here, and I'm going to go down 2. Take this top point here. I'm going to go down 2. Oops, that one was kind of at a half, so down 2 would be there. And then this one would go down to here. And then this one would go down to here. So if we're drawing our new graph, it looks something like that. So the whole graph shifted down 2. So for the next one, we have g of x equals f of x minus h, which is going to be a not a vertical, it's going to be a horizontal shift. And if it's minus 2, we're going to shift to the right. So let's just go back up and show you this part. It says if h is positive, the graph will shift right, and if h is negative, the graph will shift left. But the formula is x minus h. So what's happening here is x minus 2, the h is positive 2. I'm subtracting a positive 2, so I'm going to shift to the right. So here's the deal. If you see a minus sign for a horizontal shift, that minus sign, x minus h, that's a shift to the right. And if it's a plus h, it'd be a shift to the left. So it's kind of, for this one, it looks like it's opposite. Okay, so every point is going to shift. So I'm going to take several points. And we're going to shift to the right 2. Remember, they counted by 2s. So shift to the right, shift to the right, shift to the right. This one goes to the right 2. Alright, so that one shifted to the right 2. Okay, so shifting a tabular function vertically. A function f of x is given in the table below, and we're actually going to do a vertical and a horizontal shift. So we're going to do part A, and then we're going to do part B. So for part A, we need to make a new table. We're going to write the new points. Okay, so we're going to do a vertical shift. We're going to go down 3. So that means we're going to subtract 3 from each of our y values, or f of x values. So 1 minus 3 is negative 2. 3 minus 3, so I'm subtracting 3 from each of these. So 3 minus 3 is 0, 7 minus 3 is 4, and 11 minus 3 is 8. No, yes, that's right, 8. Alright, so that was part A. Now let's do part B. Okay, so for this one, we have f of x plus 3. And remember, the formula is x minus h. So h in this case would be negative 3. So because we're subtracting negative 3, so h would be negative 3. So we're going to subtract 3 from all the x's. And my new table we get negative 1, 1, 3, 5. And then the y's, or the f of x's, stay the same. So we only shift the x's. Alright, let's look at a graph. Graphing functions using vertical and horizontal shifts. So given the function f of x equals square root of x, graph the original function f of x, and transformation g of x equals f of x plus 2 on the same axes. Is this a horizontal or a vertical shift? Which way is the graph shifted, and by how many units? So for this one, you've got in parentheses, and so just want to show you the difference up here. Alright, if it's in parentheses, the shift is in the parentheses, that's a horizontal shift. If it's outside the parentheses, that's a vertical. So this will be, we'll go ahead and answer this. This is a horizontal shift, and it's plus 2, okay? But that doesn't mean the h is positive. because the formula is minus. So what do we subtract to get h plus 2? X plus 2 rather. So x minus negative 2 is the same as x plus 2. So in this case, h is negative 2. So it's a horizontal shift to the left. Okay, so first we're going to graph f of x is equal to the square root of x. So that's the point 0. The square root of 0 is 0. The square root of 1 is 1. I don't know the square root of 2 or 3, but the square root of 4 is 2. So I've got the point 0, 0, 1, 1, and 2, 4. If I had more graph, if I kept going, then I have the point 3, 5. There are no numbers to the left of that, or no points to the left, because you can't have the square root of a negative number. And there's no points below either. That's your graph. So now, if we want to take and graph g of x, which is f of x plus 2, we're going to shift everything 2 places to the left. So take each of these points and go over 1, 2. So each of these points, so this point here, go left 1, 2. This point here, go left 1, 2. And then we'll just connect them. They'll make the same shape. It's just shifted to the left 2 places. Combining vertical and horizontal shifts. First, if you're given a function and both a vertical and horizontal shift, sketch the graph. So to do this, we identify the vertical and horizontal shifts from the formula. The vertical shift results from the constant being added to the output. So we're going to move the graph up for a positive constant and down for a negative constant. The horizontal shift results from a constant added to the input. So move the graph left for a positive and right for a negative constant. And that goes back to that negative h thing. And then apply the shifts to the graph in either order. So let's look at this graph. So we're starting off with that same original graph. So 0, 0, 1, 1, 4, 2. So here are the original points right there. So now let's write down what's going to happen. This right here, that tells us we're going to go right 1. And then this tells us we're going to go up 3. So each point we're going to go right 1 and up 3. So take that first point, we go right 1, up 3. Then take this point, go right 1 and up 3. And take this point, go right 1 and up 3. It is the same shape. It just moved right 1 and up 3. Identifying combined vertical and horizontal shifts. So here we're trying to go backwards. They give us the new graph and we need to write the equation. So first we have this function f of x equals x squared. It's graphed. It is not graphed, rather. The transformed graph is what has been graphed. So just to show you, because this won't hurt, x squared has the points 0, 0, 1, 1, and negative 1, 1, and then 2 up 4 and negative 2 up 4, because we're squaring. Makes the parabola. Alright, so now let's just look from just the origin. We're going to go that vertex point. I'm going to go down 3 and right 1. So we're going down 3, right 1. So we'll call the new function g of x. It equals f of x. We're moving right 1, so that would be minus 1, and down 3 would be minus 3, right? So right 1, down 3. So minus 1, minus 3. So then in the function itself, remember that was x squared. So this would be x minus 1 squared minus 3. Alright, so you guys try to sketch the parent graph or our toolkit function graph and the graph of the transformation. So pause the video, try it, and when you come back, we'll graph it. We'll go over it. Okay, so the original graph is absolute value, so that's the point 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. And the points negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5, negative 6, 6, negative 7, 7. So that is the original parent graph. This is f of x is equal to the absolute value of x. So let's look and see what it is that we're going to do here. What does that tell us to do? That tells us that we are going to go right 2 places. And this tells us we're going to go up 4 places. So we're going to take each of our points, and I'm just going to take a couple here, and we're going to move right 2 and up 4. So right 2, up 4. And take this one, right 2, up 4. Right 2, up 4. Right 2, up 4. Right 2, up 4. And there we go. Alright. So this one says, write a formula for a transformation of the toolkit reciprocal function that shifts the function graph 1 unit to the right and 1 unit up. So let me just remind you, this is the reciprocal function. So we want to go 1 unit right and 1 unit up. So pause and then come back when you're finished. Unpause when you're finished. Okay, so f of x equals 1 over x. We're going to shift it to the right 1. So for shifting to the right, we're going to subtract 1, and then we're going to go up 1. So what that looks like is we take the function, which is 1 over x, and we subtract 1 from the input, and then we add 1 to the entire function. So here's our new function right here. Okay? And they don't say to graph it, but I'll go ahead and graph the original function. We'll do that in black. So, well, actually, we'll do that in another color, and let's do pink. So for this, remember they're asymptotes that it doesn't cross. So it doesn't cross y equals 0 or x equals 0, not for the parent function anyway. So we have the point 1, 1, the point half 2, and the point 2 up a half, and it curves like that. a mirror image here. It curves like that, never crosses the asymptotes. Now, we're shifting, so let's shift, and we'll do blue. Okay, so I'm going to take one point here. I'm going to take that first point. Actually, before we do that, let's shift the lines. We're going to shift the vertical asymptote. We're going to shift it one to the right. So now that's here. It's not going to cross there. And we're going to shift the horizontal asymptote one up. So vertical shifts one to the right, and the horizontal shifts one up. And then we take each of the points. I'm going to take this point here. I'm going to move it right one, up one. So move everything right one and up one. And so it looks the same. It's just shifted. And so for the bottom part of the graph, right one, up one. So there's the new graph. Sorry about that. Okay, this video is going on for 22 minutes, so we're going to pause here and we'll pick back up in part 2.